Hello, my name is Tyler Nagy, and my experiment was done on which bow design is the most efficient. There's 3 different boats constructed with 3 different types of bows. Boat A had a bow design of a 40-degree raise. Boat B was a cube, and Boat C had a V-shaped bow. The hypothesis of the experiment was that Boat C with the V-shaped bow would be the most efficient because given its V shape, it would break the water tension and create the least drag, thus making it the most efficient. Throughout the experiment, Boat C was the best while traveling through water at 60 centimeters distance with an average time of 2.84 seconds. At second, Boat B, which had a cube shape, had 3.149 seconds. And last place, Boat A, with a 40-degree raised bow, had an average time of 4.79 seconds. I don't know.
Okay, I cut all this out, no problem. Can you talk about your pictures and...
For the procedure, you had to do 2 procedures. You had to build the boats, and then you had to put the boats in a tub of water with 14 quarts of water with a Honeywell fan and have it at high speed. I did 30 trials for each experiment, which came out to be 90 trials total. It took me about an hour for each set of trials, and the results stayed pretty consistent, with averages of Boat A at 4.79, Boat B at 3.49, and Boat C at 2.84. And you didn't need all that many materials. You only needed 2 styrofoam blocks, which cost $4 a piece, and you can get those at Walmart. You needed a knife, a Sharpie, a protractor, jumbo popsicle sticks, a plastic tub, water, a Honeywell HFD air purifier, and nickels for weighing down the boat. Each boat came to a final weight of 2 ounces, when they all needed about 9 nickels. That's pretty much it. And this is my science fair project, I guess.
Hi, my name's Alec Gill, and this is my science fair project on nanocrystalline solar cells. This project introduces how different dyes, organic dyes, affect the voltage output of these solar cells. And these solar cells use titanium dioxide and organic dyes to create voltage or electric output. And some background on the nanocrystalline solar cell is that they were created in the 1800s when scientists first discovered silver chloride-based paper was sensitive to certain organic dye molecules. And they're very interesting because they're very cheap, and we could afford them for long-term projects on homes and different projects for industrial applications. The only problem is they're very short for their lifespan, and they're very inefficient. So in science, or later in science and technology, we might be able to improve their efficiency and their lifespan. Well, I tested 3 different dyes: pomegranate, blackberry, Bing cherry, and red raspberry. And my results show that pomegranate and red Bing cherry were about the same in their voltage output. Blackberry and red raspberry, though, blackberry was the least had the least voltage output, and red raspberry had the highest. And a brief explanation on how this works is that the titanium dioxide when the dye or the titanium dioxide is based onto the slide or baked onto the slide, and when you add the dye absorbs into the titanium dioxide, and maybe the dyes have certain molecules that maybe give up more electrons when the photons hit them, and that's about it. It's really interesting, and maybe we might be able to improve the efficiency, like I said. And my name's Alec Gill, and that was my experiment.
Hi, my name is Christina Spanos, and for Science Fair, I did which type of liquid has the highest rate of heat transfer. For the liquids that I used water antifreeze, motor oil, and automotive transmission fluid. I had two sections, the cooling test and the heating test. In the cooling test, you have aluminum blocks, and you put them in the freezer for 2 hours, and then after they're at 0 degrees Celsius, you drop them into 50 milliliters of the test liquid and see how much the temperature ranges using a data acquisitioner, which is a tool that's used to measure anything, but in this case, it was used to measure temperature. And then in the heating test, you put the aluminum blocks in a pot of boiling water, and then once they reach 100 degrees Celsius, you drop them in 50 milliliters of the test liquid again, and then see how much the temperature difference is. To figure out which liquid had the highest rate of heat transfer, I used the slopes of the first 20 seconds of my test. And water had the highest rate of heat transfer out of all 5 of the liquids. In this is how it was set up. You have the data acquisitioner and the test liquids. And then in this one, it's me trying to do it. The data acquisitioner is connected to a computer, and it records all of the data for every single second. And then in this one, it's me doing it again. Okay. My name is Christina Spanos, and this was my Science Fair project.
Hi, my name is Lauren Ackerman. I'm 7th grade, and my project is, does mass affect the burning rate of wood? My statement of purpose is to determine if mass affects the burning rate of wood. My hypothesis is that hardwood will burn longer than soft or medium wood when exposed to a torch because it has a higher density. I use 12 different types of wood. I use spruce, pine, cedar, buckeye, sweet gum, cherry, walnut, cottonwood, oak, ash, maple, and Osage orange. I also used a propane torch and a stopwatch. And my procedure was to place one piece of wood in the stand and then hold the propane torch 1 centimeter away from the piece of wood and to start the flame and start the stopwatch. And you have to keep the flame ignited the whole entire time while the wood burns. And you have to wait until the wood breaks and burns all the way through. And then you stop the stopwatch and shut off the propane torch and record the time. And you repeat those steps each time for every piece of wood. And some of the observations I observed were some of the woods produce sap, like pine woods produce sap. Some of the woods were very smoky, and some crackled, but others just, like, some of them wouldn't burn through at all. And my chart has the average each trial time in seconds, and then it has the average time. And my graphs have the weight of each wood, the average weight of each type of wood, and soft, medium woods, and hardwoods. And my conclusion was that mass is affected by, the burning rate is affected by mass, but there are also other things that affect it. because walnut was walnut took the longest time to burn, but it wasn't the hardest type of wood. The hardest type of wood was Osage orange, but it had one of the shorter times. So, my name is Lauren Ackerman, and I tested if mass affect the burning rate of wood.
Hi, my name is Trey Wagner. My science fair project is, do sound waves affect the growth of plants? The hypothesis of the experiment is that the radish plants, when growing to the sound waves of music, will grow at a faster rate and germinate earlier because of the vibrations of the sound waves. The procedure is that I will make the 2 pots, as you can see here, and the 2 bags, and then every day I will water them, and I will also take a picture and measure them in centimeters of how much they have grown. Also, my observations are that during the whole experiment, the radish plants did not grow at a completely steady rate. They grew for a while, and then they would decrease a little bit, and then they would keep going. And also, I noticed that the plants throughout the whole experiment would not get lighter in color. They just kept getting darker. Also, I noticed that the plants that did grow to the music, that have the red background as the red wall, did grow at a faster rate. Also, my conclusion is that this happened because of the vibrations in the sound waves gave the plants extra energy to grow just besides sunlight. That's why they grew at a faster rate. My name is Trey Wagner. This is my project.
Hi, my name is Marissa Petticord. My science fair project was, will sugar and acid affect needle loss of pine trees? I developed the idea for this project because being the youngest one in my family, during the holiday season, I would always have to climb underneath the tree and pour solutions of Sprite and aspirin into our tree to keep it alive. I took that one step further and broke it up into the sugars and the acids to see what really affects it to help a pine tree hold its needles in. Now, as you can see, over here my hypothesis was whether a solution of distilled water, sugar, and lemon juice would help a pine tree hold its needles in better than solutions of distilled water and sugar, and distilled water and lemon juice. That hypothesis was proved correct. And distilled water with lemon juice and sugar was the best solution, which helped the pine trees hold its needles. This is because lemon juice has acid in it, and acid is known to help a plant drink more water and hold its needles in. It also has sugar in it, which replaces the glucose that is made by a plant during photosynthesis. So it helped keep it alive. I took some pictures showing how I set this up, and I used certain tools such as pH strips, which were supplied by my science teacher, and a hygrometer, which is a special instrument that will measure the amount of sugar in a solution. My conclusion was that the hypothesis was correct. The second best solution was distilled water and sugar in all 3 trials. But if you do have a live Christmas tree, you should use a solution of distilled water, sugar, and lemon juice. My name is Marissa Petticord, and my project was, will sugar and acid affect needle loss of pine trees?
Hi, my name is Allie Schill, and this is my project. The title of my project was The Impact of Caffeinated Beverages on the Human Heart Rate. The purpose of my project was to determine the consumption of caffeinated beverages on the human heart rate. My hypothesis was that the heart rate will increase over an hour when you drink a caffeinated beverage. What I did was I had an adult drink a beverage. My 5 beverages were water, Mountain Dew, Starbucks Frappuccino, 5-Hour Energy, and Monster Energy. I tested their heart rate with a oxy heart rate thing, and that's what I used. My procedure was to check their heart rate every 15 minutes for an hour, and my conclusion was that your heart rate will increase determining how much caffeine you drink. These are the graphs that I made, and I found out that your heart rate will go up on how much caffeine you drink. Again, my name is Allie Schill, and this is my project.
Okay, I'd like to welcome everyone here tonight. This is our annual Science Fair Awards ceremony, and it's one of the few nights that we have set aside for academics, so it's really an exciting night for the kids here. It's nice to see you all dressed up. There are a few people I'd like to thank. First of all, I'd like to thank the parents and the students for their hard work on these projects. I'm a parent. I know how much work these things are, so please give yourself a round of applause. And next, Ms. Miller and Mr. Smith put in countless hours to make the Science Fair a successful experience for the students, not only here at the school, but also so that they can have success at regionals and at the state Science Fair as well. So I'd like to say thank you to both of you for all your work, and if you could please give them a round of applause too. And that's enough from me, so we might as well get the awards started, and I hope you enjoy the night. Maybe. Okay.
Great, thank you. Welcome. Thank you for attending this year's Science Fair. As you can see by the displays, the students have put a lot of time and effort into the projects. This project incorporates the subject areas of science, reading, language arts, math, history, and art. As Mr. Cook had said, the students have spent many hours at school and also at home working on their projects. We want to thank all the parents, guardians, family members, and staff members who have assisted the students with the projects. For the judging this week, the students were judged in 4 different categories. First was knowledge achieved. What did the student learn during the experiment? Next was use of the scientific method. Were they able to identify a problem and conduct an experiment? Next was clarity of expression, how they actually spoke when they did their presentation. And last was originality and creativity. Did they do a project that was unique? We have many awards that will be presented tonight. We'll begin with certificates and then we'll move to special awards. Honorable mention and good will receive certificates. Excellent projects will receive a certificate and a red ribbon. Superior projects will receive a certificate and a blue ribbon. Students who receive certificates or ribbons should come to the front of the room and you can receive your award from Mr. Smith or Mr. Cook. Please make sure you hold your applause to the very end so we're able to keep it moving. We know that you're anxiously waiting for the awards, so let's get started. Holden Deshay, good. Matthew Lambert, good. Kyle McClelland, good. Jacob Russell, good. Benjamin Bruner, good. Nathan Brenneman, good. Brittany Commit, good. Alex Toth, good. Bradley Kirkwood, good. Haven Pruitt, good. Erica Relke, excellent. Jacob Talento, excellent. Derek Stead, excellent. Elena Berberick, excellent. Haley Mazarik, excellent. Emmanuel Nazario, excellent. Jared Pierce, excellent. Robbie Thorne, excellent. Max Wilson, excellent. Abigail Hill, excellent. Leah Wright, excellent. Alexis Valentine, excellent. There you go, Leah. Veronica Vance, excellent. Caleb Cook, excellent. Nicholas Dobbins, excellent. Kaylee Fields, excellent. Madeline Camp, excellent. Zaya Dillon, excellent. Caitlin Fairnick, excellent. Dorothy Fitz, excellent. Wendy Hager, excellent. Evan Snyder, excellent. Selena Shaver, excellent. Cody Pierce, excellent. Gregory Packard, excellent. Sarah Martin, excellent. Tyler Nagy, Superior. Lauren Ackerman, Superior. Nicholas Zehe, Superior. Olivia Trout, Superior. Tiffany Jordan, Superior. Justin Watkins, Superior. Emily Biltz, Superior. Kayla Clark, Superior. Kevin Decato, Superior. Bradley Hune, Superior. Heather Ketchum, Superior. Anna Koroski, Superior. You're welcome. Congratulations to you. Ashley Laws, Superior. Ina Nikolova, Superior. Jessica Ralph, Superior. Kayla Peebles, Superior. Brianna Tran, Superior. Christina Spanos, Superior. Danny Rich, Superior. Alec Gill, Superior. Melina Willis, Superior. Hannah Work, Superior. Trey Wagner, Superior. Allie Schill, Superior. Marissa Petticord, Superior. All right, we're now going to move on to the special awards. First is the Science Department Award. This goes to Danny Rich. Does temperature affect viscosity? Also receiving the Science Department Award, Heather Ketchum. What color car goes the fastest? Our next category is the Scientific Achievement Awards. Christina Spanos, what type of liquid has the highest rate of heat transfer? Trey Wagner, do the sound waves in music affect the growth of radish plants? Tyler Nagy, what bow design is the most efficient? And Marissa Petticord, does sugar and acid affect needle loss of pine trees? Next, we have the principal awards. Lauren Ackerman. Does the mass of wood affect its burning rate? Allie Schill. Does a caffeinated beverage affect the human heart rate? Nicholas Dobbins. How does the mass, shape of an object affect its velocity when sinking through water? And Bradley Hune. Which model car travels quickest down a ramp? Our next category is the Specialized Area Awards. First, we have Manufacturing Science Research. This goes to Jessica Ralph. Her project was which metal corrodes the fastest in water? For Energy Research, Alec Gill. How do different organic dyes affect the voltage output of a nanocrystalline solar cell? In the area of agriculture and biological research, this goes to Anna Koroski. Which soil helps marigolds grow the fastest and quickest? You're welcome. Congratulations to Yana. In the category of water resources research, this goes to Kevin Decato. What are the effects of acid rain on coins? In environmental science research, does sugar and acid affect needle loss of pine trees? This goes to Marissa Petticord. In aviation and space science, Ina Nikolova, does the shape of a parachute affect its air velocity? In the area of persistent investigation, this goes to Kayla Clark. Which type of wood is more buoyant? Next, we have quantitative literacy. This award is presented to Hannah Work. What is the average maximum number of digits that people can remember? And in engineering sciences research, Emily Biltz. Which type of bridge can hold the most weight? Next, we have the project medals. In the area of chemistry, this goes to Alec Gill. How do different organic dyes affect the voltage output of nanocrystalline solar cells? Yes. In the area of health medicine, Allie Schill. Does a caffeinated beverage affect the human heart rate? In engineering, Tyler Nagy. What valve design is the most efficient? Also in engineering, this goes to Christina Spanos. What type of liquid has the highest rate of heat transfer? For environmental, Lauren Ackerman, does the mass of wood affect its burning rate? Also for environmental, we have Jessica Ralph. Which metal corrodes the fastest in water? For biology, we have Trey Wagner. Do the sound waves of music affect the growth of radish plants? Our next category is going to be exceptional achievement plaques, and we have 2 that we're giving out this evening. The first one will be going to Lauren Ackerman. Does the mass of wood affect its burning rate? Our next plaque will be given to Christina Spanos. What type of liquid has the highest rate of heat transfer? Our final award this evening is the John F. Bauer Award. Mr. Bauer was a science teacher at Sheffield Middle School for many years. He's always been highly respected as a science teacher. This award is presented to honor him, to recognize all of his efforts and his contributions to Sheffield Middle School. We also recognize his devotion to the science department and for his countless hours of dedication to the science fair program. He always wanted students to succeed and provide opportunities for student success. So tonight we honor him with this award. This award is presented to a student who exemplifies Mr. Bauer's dedication to science. This year's John F. Bauer Award recipient is Alec Gill. His title for his project was How Do Different Organic Dyes Affect the Voltage Output of Nanocrystalline Solar Cells? Now we have a couple other science fairs that students may have the opportunity to attend. One is the Northeastern Ohio Science and Engineering Fair, and that will be held at Cleveland State this year. The second one is the Mohican District Science Fair, and that's going to be held at Ashland University. And qualifiers for these science fairs will be announced within the next week. This year, the International Science Fair is going to be held in Pittsburgh, Pennsylvania. Any student who received an excellent or a superior need to bring their ribbons and certificates to school on Wednesday because we'll be taking pictures. Also, if you're a person who received a plaque this evening, you need to bring that also on Wednesday because we have to prepare for them to be engraved. At the conclusion of the program, what we'd like for you to do is we need to collect the paperwork that you had for your projects, the statement of purpose, the hypothesis, all that stuff. And some of you have it in binders, some of you have it stapled together and you have it on the table. We're going to have you put 2 piles up on the table. If you're in my class, will you set your papers on this corner of the table? If you're in Mr. Smith's class, set it on that side of the table. What we need to do is we need to collect those because for some students we need to give you grades for class, so you need to bring those in so we can have those. If for some reason you don't have it here this evening that you already took at home, will you please bring it in tomorrow so we can start grading those? I want to say a special thanks to all the students, parents, and staff members who attended tonight's ceremony. And you need to make sure that your projects are taken home before you leave this evening. If you're really good friends with somebody and you know that they didn't come to the ceremony for some reason, will you please make sure that you grab their project, and if I have them in class, you can put it in my room. If you have Mr. Smith, you can put it in Mr. Smith's room. We just want to make sure that they get taken down so that we can take the tables down. And thanks for coming this evening. We appreciate it.